Alright, an introduction to 400 hertz electrical distribution system, J. Paul Geyer, PERA. Introduction to general consideration of three designs requirements. This publication is for Unified Facility Criteria, United States Government, public domain, authorized and limited distribution, not copyrighted. Tables and formulas. Publication may be at this time a little difficult to read, but they are best available. Do not purchase this publication if the limitation is unacceptable to you. 1. Introduction. The scope of the discussion includes the information necessary for the proper design of 400 Hz conversion distribution utilization system. Special regard is paid to system utilization, medium voltage distribution. General consideration uses aerospace electrical equipment that generally operates at an input of 400 Hz electrical power supply with the aircraft generator would normally receive the energy from the aircraft engines. Three-phase aircraft generators to 3,000, 4,000 RPMs depending on the engine speed, synchronized with the 400 Hz output voltage for distribution aircraft equipment. Large aircraft may have several hundred electrical motors used at 400 Hz, provide considerable weight saving. Three-phase 400 Hz open frame units, 1 to 15 horsepower in size, speeds up to 12,000 to 24,000 revolutions per minute. Develop the aircraft having weight averaging 2 pounds per horsepower and open drip drop proof. 60 Hz, 1,800 revolution per minute unit of unit 1 horsepower to weighs about 40 pounds. Two high types of system of supplying 400 Hz with ground power operation, frequency conversion, equipment of the 60 Hz input to 400 Hz output, rotary converters to motor generator, solid state converters used for the purpose of this fixed service point. Units for the avionics, equipment of the aircraft with the connected with the inner supply with either nearby frequency conversion assembly with a low voltage feeder with the system and the for more remotely located to 400 Hz central plant use medium voltage feeders. Rotary converters, motor generator sets are used in both low and medium voltage. These units are usually limited to installation in industrial location due to the high level of noise produced. Solid state converters are usually only low voltage system noise level to produce. They are used the more motor generator set. MG sets are substantially less than industrial trends. The rotary machinery with solid state converters distribution systems. Fixed service point units for the avionics equipment and aircraft are supplied by either nearby frequency conversion and assembly low voltage feeder system from more than remotely located 400 Hz central plant using medium voltage features. Low voltage systems. Currently, low voltage systems distributed volts less than 600 volts become the reactive electrical power system and is greater than 400 Hz. Less than then at 60 Hz, attention must be given to both central circuit length and the conductor size do they maintain acceptable voltage regulation. Consequently, the loads of the distribution distance increase. Low voltage systems require excessive feeder systems reside in installation of numerous local frequencies conversion assemblies. When numerous local frequency conversions assemblies are used, reliability of the system is increased. Typical 400 Hz low voltage system shown in figure for 1A, 1B. Detailed requirements provided in appendix B. Medium voltage system. The development of the medium voltage system distributed three-phase 400 Hz electrical power to 4,160 volts provided a more economic system than a typical 400 medium volt system shown in figure 1. Flight line and electrical distribution set or FLED systems maybe in conjunction with a low voltage medium voltage system. The components of the individual flight line electrical distribution set here shown in figure 1, flight line electrical distribution system consists of a number of FLED sets distributed in 2000 Y at 115 volts at 400 Hz, a maximum of 2 aircraft flight in electrical distribution set. Surveys before replacing existing low voltage systems with central medium voltage systems make preliminary surveys to ensure the cost effectiveness of the replacement, energy conservation, fuel load efficiency of the motor generator set portion, frequency conversion assemblies ranges from 73 to 88%, depending on the size of the set, the type of the motor, with the induction synchronizing the use of many of the sets without operating under load, lower efficiencies, increasing energy use and cost, and probable increased maintenance in a short one's operational life. Economic studies. When preliminary surveys studies would indicate that the central system of the economically feasible complete life cycle with the cost analysis being necessary, making the field measurement of the actual demand loads of the existing low voltage 400 Hz system, determine power requirements, characteristics, location, all existing utilizing equipment, service the point of the using Agencies shall be divided with all changes of the load requirements contemplated with a survey of the anticipated missing changes so the information may include and determine the capacity required by the central system. 2.5. Type of loads. Various type of loads with required 400 hertz electrical power input. The power factor of these loads varies from 0.8 to 1.0. Aircraft, the number each of the aircraft served to determine the total demand. The computation of 400 hertz aircraft loads of the maximum load in Table 1. The demand factor applied on the total load given in Table 2. And then shows your picture of a 400 hertz medium volt system. Then a 400 hertz low voltage system. Your junction box, aircraft service point casting, flamp section, and then modified distribution box assembly. Example 1, Example 2, example of the typical flight line electrical distribution system. Aircraft load type, maximum kilovolts for 1.4 service cable requirement, 2 service cable required. Number of aircraft and demand factor present, representation and representative system demand factors. R25 avionics. In addition with the aircraft over other than loads and such for the repair shops, electronic equipment that requires 400 hertz electrical power with the maintenance and testing and load requirements shall provide by the owner in such a cases, other facilities, research, development, training, other type of requirement facility that may require 400 hertz distribution system owner may not provide load requirement compute such load with a watt per square meter because for the firm loads if they're not available the square special requirements. Facilities indicated above that have more stringent 600 hertz power requirements of fixed point utility systems provided prior to the supply of these facilities of fixed point utility systems equipment installed will not be damaged. Fixed point utility system power tolerance. Use local conversions of these systems. 2.6 Consideration of system voltage parameters inductive of the distribution reactive. The voltage drop of 400 hertz system is roughly 7 times greater than 60 hertz system, and the necessity certain demand modification for the conventional distribution utilization system depends. Designs compensate with the increased voltage drop specification limiting voltage drop covered in a later section, but power requirements applied generally to 400 hertz system. Develop the guideline of the parameters. Voltage drop is always the concern during the design of the 60 hertz system, giving an even closer attention to the voltage parameter design 400 hertz system because the voltage drop is much larger. Design 400 system taking account the effect of the varying cable length of the connection loads, items, and affecting the design. The designer must consider the maximum load applicable to cable length limitations based on acceptable end voltage requirement to determine the maximum allowable cable equipment. Impedances method of to be the compensation and limitation. Impedances are important also overcompensation. Voltage drop can be made bad under compensation. Voltage range which provides the safety aircraft power key element acceptable at 400 hertz distribution system. Acceptable end voltage requirement, the voltage ranging from 108 volts minimum to 118 volts maximum specified by the operating voltage range of the equipment inside of the aircraft. The operating voltage takes into account the 0 to 5 volt drop and electrical distribution system inside of the aircraft. Accordingly, the full load and no load voltage interface for the aircraft connection input power point should never drop below 113 volts nor rise higher than 118 volts. The parameters always also apply the inputs of the flood system equipment and the cable parameters. Rotor equipment cable, the parameters usually with the designer given in Table 3, 4, and 5. Some of the parameters directly affect the voltage drop, but the other parameters vary with the information only. Equipment cable, the descriptions corresponding shown in Figure 1. These voltage values are used to determine the maximum cable length, medium voltage feeders, low voltage service circuits for aircraft cable connections, plus with the permissible number of the units load per feeder cable. Equipment providing lower voltage drop parameters acceptable. Unit loads based on the here and the voltage drop calculation. The individual 100 amp, the 0.8 factor load with 100 amp unit loads can be supplied at 75 kilovolt amperes utilization service center. Maximum cable length and loads. Determine the maximum cable length loads effective with the service systems parameters. Various conditions were analyzed. Table 6 show the maximum number of the unit loads connected to medium voltage feeder meet the minimum voltage level of the utilization service available. allowable in the medium voltage distribution level, and provided that the medium voltage distribution level at 4,160 volt for the commercial airport, and using 400 hertz system voltage up to 2,500 volts. However, in these cases, the feed lengths or distance of the much shorter of the feed length for the system, even the military airfields, 2,400 volt system provide no appreciable cost savings across the requires production maximum feeder length with 1/3 acceptable ends on a 4,160 volt system, which serve the same load, and in the feeder lengths are not required. Then the 2400 volt system is capable of serving only 1/3 of the load that can be fed in by the 4,160 volt system. Maximum cable lengths normally do not extend the cable length with the value given in Table 7 of the medium voltage cable in Table 8. The low voltage cable, the reason for the only 4-unit loads permitted in Table 7 effects for the low voltage cable were considered. This is not the case in Table 6. The use of 4 loads maximum meaning the steady state load plus the steady step load cannot be exceed 400 amperes as shown in step load cable columns. Exceeding the limiting cable length, justifying exceeding the normal cable length limits only as when the limitation requires another central plant at 1,500 feet feeder cable length and may not exceed by 10% increase the more over 5% must approve the loan by the owner. Due to special site conditions, the aircraft cable length at such site may be increased to 70-foot length and only if approved by the owner. Rational maximum cable lengths. The essential factor of determining acceptable cable lengths is 113 volt limitation. Aircraft interference point may the limitation in the following manner. Permit steady state voltage drop at 3,918 volts and on the 4,160 volt end of the medium voltage distribution system. Droops define the absolute change of the voltage between the steady state and no load condition, steady state, full load condition. This equals 113 volt voltage distribution system, or 0.942 per unit volts per using base voltages at 4,160 volts and to 120 volt terminals. Utilization services assembly make up the low voltage system drop compensation low voltage system requirements, synchronizing unit revolving fields, transformers, frequency conversion assembly and parameters, the motor, power factors, and generator. Transformer line drop compensators, passive element filters, medium voltage feeder cable, low voltage service cable, cable parameters, maximum unit load feeders, and then maximum 400 hertz medium load cable lengths and load lengths, maximum 400 hertz low voltage cable lengths. Alright, Chapter 3, Design Requirement. Design Procedure. Preliminary design procedure. 400 hertz systems are the same as the 660 hertz cycle with the load distance except for the system design will meet the procurement requirements. Data gathering. Determine the following data regardless of whether an entire new installation of the design existing facility that is being changed. The upgrade of the new facility allows only more leeway in the design approach available. The load data that ordinarily will not be precise. Gather design concurrently with the 400 hertz system following data. Faulty electrical site plans, location, aircraft service points, faulty electrical building unit plans with having 400 hertz loaded used in to house 400 hertz equipment to determine all 400 house loaded specification include, but the requirements for the new loads replacement for using 400 hertz low voltage conversion distribution system data for the proposed install for 60 hertz primary distribution system. System layout from above data that develop the system layout with the location for the possible distribution line choices, pinpoints, load connection points. Equipment layout after the development of the system layout with the make of the equipment location based on the design aspect delineated with the following paragraphs. Design aspect. 400 hertz consists of the following major elements: central power plant, medium voltage distribution system, low voltage utilization system. Following consideration applied to the entire 400 hertz system design. Protective device operation. Always consider the thermal and magnetic characteristics of 400 hertz circuit. Protective device operation. 400 hertz causes the more height rise of current carrying parts than does operating at 60 hertz. There is and also the decreased electromagnetic pull on the magnetic triple elements because all of the current rating devices are affected with a different degree of considerable applicable to rating factors during the design phase. For the appropriate manufacturers to determine the rating is appropriate with the equipment and also special calibrate thermal and magnetic characteristics of protective devices for using 400 hertz. Surge arresters. Per surge, provide surge arrestor with a 60 hertz system protection necessary in general with the only exposed lines below those 60 hertz distribution system. Therefore, provide a 400 hertz protection only for the devices for the insulation cable that is below provided by the 60 hertz 60 per surge protection, which will normally protect the medium voltage 400 hertz device varistors available for the use of the low voltage 400 Hz system, and you can limit the surge at about 1.7 times peak voltage provided where required. When using agency furnished detail with the equipment required the other than various varistor protection 400 Hz electrical equipment sensitive to the voltage spikes low as 1.5 times the nominal voltage veneer type of suppressor silicone avalanche diodes can limit the voltage at 1.38 per unit provided the 3 Xenier type suppressors normally with the equipment terminals, bus and cable material because of the low resistance use of the copper, except for such use of the clearly impractical to find fully justify use of any other of the copper design analysis. Arcandunity, the presence of the magnetic material in the vicinity of the electrical conduction increase the flux density with the increase of the resistance and inductancy, but therefore non-metallic magnetic materials such as aluminum, plastic with a raceway with a non-magnetic material such as the aluminum, bronze with the plastic is appropriate for the cable termination clamps, other equipment. Medium voltage distribution system designed to cover the 15,000 feet with the maximum feeder length to dictate for the number of locations acceptable to the center plate within the sites. Make the layout with the minimum voltage feeder for lines first. Type of the distribution, generally used for the raceway with the distribution 400 Hz circuit with aerial 400 Hz system precluded because of the excessive of the inductance of such circuitry with the overhead distribution system using pre-assembled messenger support with insulated cable acceptable in an area with a lighting storm. A few where aircraft clearances criteria not apply in area with the protection area. Again, lighting induces surge is a required surge arrest specifically designed for use of 400 Hz protection underground to aerial risers using 60 Hz arresters and effective hazards cause hazard because of the capacity of the elements of the arrestor for the chain with the frequency chain with the capacity. Therefore, the distribute even voltage gradients prevent premature spark over. Our practical distribution area consider 15,000 foot limit on the length of the medium voltage feeder within practical to trade half the of the installation center plan. Surfaces are likely to be limited to 2.5 mile radius. 3 or 4 site configuration permit one central plant should serve an area up to 5 miles in diameter. Chapter 2, Figure 2 shows the example of central plant hangar site plan. Alright, shunt reactor capacity installed. Shunt reactors on the medium voltage feeder balance with the capacity of the fader side of the reactor with the low power factor of the medium voltage feeder. Thus, the system is enclosed to unity nominal kilovolt ampere reactivity. Rating of the reactor may be greater than the feeder capacity of the kilovolt ampere reactive to provide lagging power factor, but should not be used more than 10 kilovolt ampere reactive as seen as the overall system indicated that normal ratings based on the maximum allowable specified capacity on medium voltage feeder. Install shunt reactors on medium voltage feeder is shown indicated in Figure 1. Field adjustment. Adjustable nominal indicating the rating of the shunt reactor with the suitable actual capacity with the able provided with the maximum field measurement of the actual capacity after the cable is installed. The correct shunt reactor can be chosen to close the unity power factor setting. Alright, nominal rating sizes with example with the nominal rating sizes show with the nominal calculated in 10 kilovolt ampere reactive per feeder. Shunt reactor may not be necessary to decrease voltage drop, however the installation provides for capacity discharge and increased operational safety. This is nominal rating of the VC squared over 1,000 times point to point X. For the 160 volts squared at 26 over 1,000 feet, or 1,666 equals 26.2. Alright, 3.3 Central Plant Design. Central Plant is deployed with a station medium voltage distribution 60 Hz and rare 50 Hz input and converted to 400 Hz power to distribution 400 Hz feeder distribution center. Station medium voltage distribution system typical 400 Hz central plant shown in Figure 3. Normally with the plant will be unnamed facility. Reliability, continuous operation, central 400 Hz medium voltage system. Extremely critical standing components required with the central plant, but they ensure the nominal no major loop of 400 Hz electrical power. System 600 Hz input power design 600 Hz input system and the covered with a handbook only extend with the previous providing necessary 400 Hz system reliability type power points inputs to different feeders electrical surface 600 Hz electrical power required in the central plant. Primary feeder source certainly provided with a primary alternate feeder for the installation 600 Hz prime medium voltage distribution system. An area of 400 Hz load large enough that they require the central medium voltage system is an area low density which is both large, sufficient, and important enough to require more than 660 hertz primary distribution feeder. Or a diesel engine generator source provide emergency diesel engine generator system alternative source for the provision alternative feeder the most costly with a standby power system provide diesel engine generator capacity at least 880% of the frequency conversion plant firm capacity. Frequency conversion plant firm capacities some of the rated capacities of all the frequency conversion assembly largest unit not operating where required by actively provide 100% of the diesel engine generator capacity provide a diesel engine generator set with both the manual automatic transfer modes will start automatically on low non-loss of nominal power. When more than one diesel engine generator set is provided with a provide capable of being automatically powered, parallel provide switches with the permit with the testing with the diesel engine generator with assuming load. Most economical diesel engine generator voltage generally with the input voltage frequency conversion assembly. Our transformer, because of the frequency conversion assembly with low voltage input device, the transformer necessary for the step down the primary power. Normally, facilities depend only on one transformer. This can result in the complete shutdown of 400 Hz system. Require duality of the transformer. Each transformer rating should not be less than 80% of the frequency conversion plant firm's capacity. Transformers over the outdoor substation type of the install with adjacent to the central plant shown in Figure 3. They can be used to supply the central plant 60 Hz low voltage switchboard shown in Figure 4. Systems of 400 Hz conversion capacity. Firm power is power which is available under emergency condition. From the firm frequency for the conversion capacity, the central plant with the load serves at 15 to 20% of the additional capacity. Future loads provide one extra unit of standby with the emergency use. Ever the requirement that the unit with the future capacity of the necessities more units than the present load of the maintenance backup of the incremental construction may be desirable to such planning is acceptable long as in the future specified with the capacity provision for the auxiliary device covered fully with the first design stage. Frequency conversion assembly rating is shown in table 3 with the provided satisfactory operation. Frequency conversion assembly performance combined with a properly designed distribution utilization system provided with 400 Hz power to the aircraft load. Figure 5 shows the tippet. Frequency conversion assembly. Alright, motor generator units used with the same by the manufacturers support both military and commercial airports. Output voltage, most preferably output voltage is the distribution system, 4,160 volts. However, the equipment is not commercial available, nominal with a special 575 volt motor generator output. Except for the system can be reused with existing motor generator set with a meet that can be adapted to meet with the criteria in such case with the U with the new generator set, which match out with the output voltage with the existing setting. Unit capacity normal to provide with 312 kilovolt and generated blast capacity with large capacity known produced the standard more than one manufacturer's synthesizer that usually most economical maximum full load efficiency. Table 9 use other units as adequate justified. And it shows a picture of the 400 Hz central plant. Your Figure 4 single line diagram of 6-year low voltage switchboard. Our vertical shaft construction minimizes floor space with 312 kilovolt vertical motor generator set weighing as much as 6 tons. It is approximately 4 feet square and 6 by 6 feet height. Same size of the horizontal unit required with a 6 foot by 7 foot floor space that can be almost as high. Their areas are loaded but do not include the rest of the assembly requirements to provide the clear capacity space of at least 3 feet above the motor generator to allow maintenance of the vertical unit. And then table 9 for the typical full load efficiencies. 3342 other components. Figure 5 show the components that are provided with and part with the packed frequency conversion unit. They ensure the units of factory design the performance requirements. Voltage setup of the matched kilovolt and with low medium voltage setup of the transformer specifically generator capacity provide voltage sensing device and transfer output regulated voltage motor generator set regulation ensure the voltage level of the medium voltage bus at 400 Hz. Feeder of the distribution center remains constant under the steady state load condition. Output disconnect vacuum contactor disconnect output of the unit rather than circuit breaker because of the contactors are both smaller and less costly. In addition, overload the short circuit protection contactor provided with over voltage, under frequency, burst power control features which are not available in the fuse switch. And it shows a picture of the single line diagram frequency conversion assembly. Single line diagram feeder distribution system. Alright, 335. Feeder distribution center. The feeder distribution service serves as the 400 Hz medium voltage system control point and output with the frequency conversion assembly with a common bus supply of 400 Hz medium voltage feed with a serve at the point with a 400 Hz feed for the correct output. This is no load power factor, almost for the balancing capacity of each of the feeder cable. Figure 6 show the typical feeder distribution system or distribution center. Metering normally do not install the recording type of the meters in the manned facility. And reader record records are retained, required and transmitted to the point of personnel available to maintain an orderly record, keep it in storage. Shunt reactors, example of shunt reactors, sign shown. Alright, your central plant buildings of the equipment shelter will reliably stand with the site of the equipment shall also possibly structure sheltering in part with the 400 Hz system and the environmental support system provide space with the around with the equipment E for the conveniency of the testing, maintenance, serving, equipment removal to provide minimum 5-foot easel space around each of the frequency conversion assembly. Large easels may be required to allow the replacement of the defective equipment, design buildings, and knockout panels for future expansion of the control mechanical systems automatically thermostat with maintain correctly the temperature under operation condition. Provide roof with exhaust fan with required with the provided levers and air handle with the equipment units and air supply with having the filters which prevent the entrance of the dust air. Operating parts, motor generator sets include other consideration normally provided with a diesel engine generator and switching gear rooms. Low voltage utilization system design. A low voltage utilization system example the utilization services available. Assembly shown in Figure 1 from the solid state frequency conversion assembly shown in Figure 1A and 1B to the parked aircraft layout. Aircraft parking defines the location of the parked aircraft units which define location number of utilization service assembly or solid state frequency conversion assembly to determine a single low, medium voltage feeders capable of supplying one hangar, several hangars, aprons, integrated with design aircraft fixed point utility system. Low voltage system equipment in addition to the utilization for the assembly with the medium voltage system. Each low voltage system included with the individual aircraft supply support source and fixed service points. Utilizing services assembly to assure satisfactory operation. Provide utilization service assembly components as shown in Figure 7. Step-down transformers normally provide step-down transformers rated 75 kilovolt ampere three-phase at 200Y, 208Y at 120 volt output through terminal rating of the 208Y at 120 volt. Consistently use high voltage rating of the distribution system. Equipment over the 200Y, 115 volt utilization equipment. Air distribution voltage level that allows voltage drop between the distribution utilization point load served is generally no more than 100 ampere 0.8 power factor units lead loads at 384 kilovolt ampere each. Special case large load requirements are been served in such case the criteria provided with using agency of the design for TACAMO loads or utilize 400 kilovolt ampere transformers. Same maximum percentage impedance value is on the table for 75 kilovolt ampere units. The line drop compensators see the medium volt feeder length of the given per unit with the voltage group as an absolute chart voltage between the steady state with no load, steady state, and full load. The 2B0942 at the end of the feeder cable, the 113 volt line is neutral on a 120 volt utilization assembly terminal voltage bay, but therefore compensate for the drop of the utilization for the assembly of the aircraft connector, so not less than 113 volts are provided with the aircraft with the interforce point of the fine line drop compensator indicating the table of 4, 75 kilovolt ampere to transfer, 460, 408 kilovolt and 400 kilovolt ampere transformer. Positive element filter assembly installed with a positive element filter assembly to reduce the harmonic which can be generated in system standard performance requirements are based on systems that do not provide our above additional harmonics in the presence of the rectified direct current load provided passive element filters equipment terminals aircraft where the loads are produce harmonics fixed service point units generally fixed to the surface of the point units provide with the distinct connecting devices for the two aircraft that provided two circuit breakers. Low voltage cable limitation location from the parked aircraft with 60 feet aircraft cable with limited location on the fixed service points. The unit with each fixed service point requires the utilization service assembly solid state frequency converter for its supply location limited maximum 200 foot service cable length with the medium voltage system voltage is limited for the input utilization service assembly defined with the same with the drop compensator indicated with the compensator setting the drawing so aircraft voltage leads and are provided with the overcompensation cover the sending independency impedance to appear with a very low and result of the current flow with the raise the voltage level above the required 118 volts see the compensator so with the limit to 113 volts minimum full load 118 volts maximum no load aircraft interface point with non-compromise under any circumstances feeder cable connection on the location utilization for the assembly will determine the calculated with the allowable number of the type of devices which can be connected with medium voltage feeder cable. 344 cable design requirement cable of 100 hertz circuit required for the design minimum voltage drops by its construction cable the parameters for the feed for the server of the cable given in table 5 that provides standard design aircraft cable to meet the requirement of military standard 9032A cable assembly external electrical power aircraft 115 to 200 volt over 200 volt 400 hertz. And it shows your figure 7 the single line utilization service assembly and then your exam. And this was a reading of your introduction 400 hertz electrical distribution systems.